Ah, gummit. There it is. Two vehicles approaching an intersection. Now we're going to get to do some actual trig. Square with the squares and stuff. Approaching an intersection. One is 2,500 kilogram pickup traveling at 14 meters per second from the east to the west. Notice it says from the east, that way, to the west, this way. That is west, believe it or not. You don't believe me, get your compass out on your phone and check it. All right. And then the other one's doing what? The other is 1,500 kilograms sedan going from south to the north. Okay? All right? Please learn your directions without a phone. You should be able to look at the sky and say, oh yeah, north, south, east, west. All right. At 23 meters per second, find the x and y components. Now listen, x and y components of the net momentum of the system. What are the, now listen close, magnitude of the net momentum. So what are we going to do on part A? X and Y. How are we going to do that? No, A, part A. X and Y components. Yeah, what we just did, right? And then how are we going to do magnitude and direction? Then we're going to do what? Square the squares, and to find direction, we're going to do what? Arctan. Very good. That's right, arctan. Now, I'm going to tell y'all something. The answer in y'all's book, I don't like it. They did the arctan crazy. And I understand why they did it, but they didn't orient it from the positive x-axis. They oriented it from 90 degrees. And I don't like doing it that way. Okay? So your answer, your numerical answer, it all depends on how you subtract it. Well, actually, when you subtract it, let me think how to explain it. If you subtract it from 90, you'll still get it. What they say in the book. But again, I don't want you doing it that way. Subtract from the positive x-axis and then give your final answer.
So what we're doing is finding x and y of each car and adding them together to find talking about the net momentum.
Yeah, you got to do the square of the squares. Now, it's really easy, y'all, because notice one of them's what? One of them is at 180, and one of them is at what? 90. So one of them has no y component, and one of them has no x component, because there's 0. Because the sine of 180 is 0, and the cosine of 90 is 0. You follow me? Yeah, but yeah, you're right. You add them up. Okay? Okay? Everybody understand what we're doing? Do your MV cosine and then MV is sine for both of them. Right? That makes sense? We good? Yeah? Yes?
Yes.
You know what we're doing. All right, good. Okay. Oh, man, we got lab today, don't we? Oh, yeah. It's momentum and impulse lab. That's a pretty good lab, too. Are y'all as anxious to get through the semester as I am?
Yes.
Y'all have had it rough. I'll give y'all that. Y'all have had this and calculus and organic. All of y'all have had organic, haven't you?
Is the 35,000 just
Yeah. Yes. Yeah, one of them's negative, yeah. Yeah. Going from east to west should be negative.
So cosine should be a negative 180?
Mm-hmm.
Inside the sine cosine.
Yeah. Because if you think about it, going east to west, your x component is negative. Has to be. That makes sense?
You don't have to top in negative 180.
No.
It would
No.
be negative.
It'll give you a 180, yeah. It'll give you a negative when you do the cosine of 180. Yeah. See, that's why I always draw it. So let me help you on the drawing. So we're going from what? South to north, and then from east to west, or east to west and then south to north. And look, you could actually do this and leave the cosine out of it. You could actually say negative 14 meters per second because it is negative if you want to, but you don't have to. And then the mass was what? 2,500 kilograms?
Just on the cosine for that one?
Yeah, because when you do the, well, you can do it that way or leave it 14 and then do cosine of 180 and then sine of 180 and then do cosine of 90 and sine of 90 on this one. Okay? Because that one's gone and that one right there is gone.
8 and 0?
Yeah, because sine of 180 is 0. Cosine of 90 is 0. Okay? And so then you have on this one, it's what? 23 meters per second? And what? 1,500 kilograms? And so what does it look like? All right, watch. You can write it this way. P total is equal to, what was that? 14 meters per second times what? 2,500 kilograms. And that would be in the x would be what? Cosine of 180 plus, do I have to do the other one? Because it's going to be 0. Plus 0, because sine of 180 is 0, plus 23 meters per second times 1,500 kilograms sine of 90 plus 0. And you should get a P total of well, I tell you what, let's do it this way. This is, let me do it this way. Let's do it P total of the truck and P total of the car, right? Or the sedan. And let's do it that way. Let's not cram it all together. Okay? All right. And so we get an answer on this one of negative 3.5 times 10 to the fourth, and that's kilograms meters per second. And this one down here, you get 3.45 times 10 to the fourth kilograms meters per second. You got it? Everybody get that? Everybody get a negative and a positive? The first one's negative. The truck is negative. Everybody see that? Because look, it's going from east to west. Cosine of 180 is negative. Sine of 180 is 0. Okay. Then on the sedan, the sine of 90 is positive. The cosine of 90 is 0. See, that's cosine of 90. Okay. All right, now we got to do what? That's part A. So there's A. Now let's do B. I got to get y'all out of here. All right. Then part B, it says what is the magnitude of the momentum? So P is what? Square root of the squares. Well, where's my x component, my y component? Well, here's your x and here's your y. How do you know that? Cosine and sine. So negative 3.5 times 10 to the fourth, and I'm going to leave the units off, squared, plus 3 3.45 times 10 to the fourth squared. And then we get what? Oh my Lord, 4.91? 4.91 times 10 to the fourth kilograms meters per second. Is that right? Everybody get that? Now what's my angle? Arc tangent. Now watch. You do have to throw that negative in. 3.45 times 10 to the fourth. You know what? I can actually leave my powers off, can't I? They'll cancel out, won't they? 3.5 times 10 to the fourth, but I'm going to go ahead and put them in. So we get an angle of what? Negative 44.6. Now wait a minute, that's not how we want to leave it. Plus 180, and we get an angle of what? 135.4. Now I know the back of your text, oh shoot, you don't have the answers in the back of the text on this. I thought you did. My bad.
Negative is your x.
Yes.
So would it be 180 minus the 44?
Yeah, that's what I did.
Oh, okay.
Yeah, it's here. I just added 180 to it. 180 minus, 180 minus 44.6 or plus, negative 44.6 plus 180, same difference, yeah. 135.4. Everybody with me? Okay? Now again, you might find a little solution a little different, but I don't like the way it worked that way. I want to work it that way. That's the easiest way to work it. Okay? Now, what if the angles were not 90 and 180? What if it was, say, 20 and 30? The x's and y's would come together. That's right, and you'd have to add both of them together and then take square root of the squares, right? Just like we did when we were doing velocity and forces. Okay, y'all, that's a good stopping point. Didn't mean to keep you over, but hey, y'all are worth it.